How to understand adiabatic mixing in Psychrometrics HVAC. Imagine two streams of air meeting in a room, each with different temperatures and moisture levels. How do they combine without losing or gaining heat from outside? That's what adiabatic mixing is all about in HVAC systems. It's a process where two air flows come together and no heat escapes or enters from the environment. The total energy, or enthalpy, of the combined air stays the same during mixing. In psychrometrics, which studies the properties of moist air, each airstream has specific characteristics. These include dry bulb temperature, which is the air temperature you feel, and humidity ratio, which tells us how much moisture is in the air. Enthalpy combines both sensible heat, which affects temperature, and latent heat, which relates to moisture. When two air streams mix, their properties blend based on how much air is in each stream. To figure out the new air condition after mixing, engineers use mass and energy balances. The total dry airflow is the sum of both streams. The moisture content is a weighted average based on each flow. The total enthalpy is also a weighted sum. For example, if one stream is warm and dry, and the other is cool and moist, the resulting air will have an intermediate temperature and humidity. But the total energy remains the same because it's an adiabatic process. You can visualize this on a psychrometric chart. The original air states are points on the chart, and the mixed air state lies along a straight line connecting those points. The position depends on the ratio of the flow rates. This makes it easier to see how temperature and humidity change during mixing. In real HVAC systems, adiabatic mixing happens often. For instance, outdoor air mixes with return air from a building's interior. This helps control indoor climate efficiently. It's also key when designing systems that use outside air for cooling, called economizers. They save energy by mixing outdoor air with indoor air without extra heat exchange. Sometimes, if the mixed air cools below its dew point, condensation occurs. This releases latent heat, slightly raising the temperature and reducing humidity. Even with this, the process still fits within adiabatic mixing, just with a small adjustment for moisture content. So, understanding adiabatic mixing helps HVAC engineers predict how air conditions change when different air streams combine. It's a simple but powerful concept that ensures systems work efficiently, keeping indoor environments comfortable and energy smart.